OMG, you guys, circles are my favorite. Okay, so before we do circumference of a circle, I just want to talk about pi for like a few minutes. A lot of you know, oh, pi is 3.14. It keeps going, actually. They don't know how many, it has an infinite number of digits. They have not discovered all the digits of pi because it's infinite. And they have like huge supercomputers that are constantly like trying to crank out the next digit of pi. It's insane. But what I want to relate to you is why why do we use this? Like, why all of a sudden in math are we using this symbol to represent a number? And then how does it help us find anything, right? Like, why? Okay, so here's what happened. Way back when, ancient times, ancient Greek mathematicians made an observation. They noticed that if you take a circle, right, and you measure the distance around the circle, that every time you measure that distance, it's a little more than 3 times the diameter. So let me show you what I mean by that. So in this circle that I have down here, let's say my diameter, actually, I have a better example. Hold on. I have a circle and I can actually change the diameter if I want, right? So I'm going to leave the diameter at 4. So it's something that we can see easily. Let me just bring this back. Okay, so now I'm going to unroll the circle, right? So what I'm doing when I'm unrolling the circle, keeps jumping, is I'm flattening out the circumference, right? So watch that again. I'm going to flatten out the circumference. All right, now I have this tool where I can show a diameter. Hold on. Click off this box to show the diameter, right? So here's my diameter. You can see it's 4, and I can compare it to the length of the rolled out circumference, right? So I can bring my diameter down here and I can count. There's 1 diameter, 2 diameters, 3 diameters, and then like a little left over, right? So let me roll the circle back again and let me change it. Let's say the diameter is 2. I'm going to unroll the circumference. So what I'm doing is I'm just flattening out that length that goes around the circle to make it easier to measure. And then I check again. I can take my diameter and I can go 1, 2, 3 times with a little left over. All right, let's try making it 5. So I'm going to roll the circle back up. I'm going to bring this all the way up to 5. I'm going to roll the circle again. And then here's my diameter tool. I'm going to measure again. I've got 1, 2, 3, and a little left over. So what the ancient mathematicians discovered is that regardless of the size of the circle, the distance around the circle will always be a little over 3 times the diameter. So mathematicians thought, this always applies. So this must be something, right? We must be onto something. So what they're saying is, okay, well, let me go back over here. So they're saying that I know that if I take the diameter and I multiply it by this magical number, it's 3 point something, right? We don't know what it is right now. It's a little more than 3. I always get the length of the circumference. So they said this number must be important. We're going to call it pi. So the diameter times pi will always give us the circumference. And then pi will always be equal to the circumference divided by the diameter. So how many times does the diameter fit into the circumference? A little more than 3. That's pi. That's all it is. They just recognized that that happens every single time, regardless of the size of the circle. They can make the circle huge and say, well, how many times does the diameter fit into that? A little more than 3. Okay, let's make the circle really tiny. Okay, so how many times does the diameter fit into the circumference now? A little more than 3, right? So they're like, yeah, that number is important. It can help us find missing dimensions, right? If we know the circumference, we can find the diameter. If we know the diameter, we can find the circumference using this magical number. It's not really magic at all. It's just a number that stayed the same regardless of the size of the circle. So they called it pi. All right, so that's what pi is. It's the number of times that the diameter fits into the circumference of the circle. Okay, so now we're going to use it. So we know that you're going to see 2 formulas for circumference. You're going to see circumference written as 2 times pi times r, and you're going to see circumference written as d times pi, or pi times d. The reason why you see 2 of them is we're just learning about the parts of the circle, right? But you may already know from 6th grade or even elementary school that what we're looking at right here that goes halfway across the circle from the center point to the edge of the circle is the radius. If you double that, right, this is another radius over here. And if you go all the way across the circle, that's the diameter, right? So I can rearrange this and say 2 times r times pi, because remember, multiplication is commutative. I can do it in any order. And really, I mean, 2 times the radius is the same as the diameter, right? So these formulas are equivalent. This is the one that I tend to use. I don't know, I think it's simpler because when we get into area of a circle, that formula also has a 2 in it. So I think it's just easier to remember the circumference formula as d pi. All right, so let's do it. So if my radius is 4, right, that's only halfway across. That means my diameter is, hopefully you said 8, right? Because all the way across would be 8. So I'm going to have 8 times pi. Now, if it says leave your answer in terms of pi, you would leave it like this. But in this problem, it says to use 3.14 for pi. So that means we're going to do 8 times 3.14. And 8 times 3.14 is 25.12. And this is area, so it is square inches. I know it's a circle, but 25.12 squares would fit inside that circle. We'd have to like cut them off, right? But the areas, that's how many squares would fit inside. All right. Oh, wait. Oh my gosh, you guys. It's not area. We're doing circumference. So it's not square inches. It's just inches. Sorry, I'm getting a little ahead of myself. It's not squares. We're not measuring squares. Circumference is a measure of length. So we're measuring how long it would be all the way around the circle. That's circumference. It's kind of like perimeter, but since it's a circle, it has a special name. So we found that the distance around the circle is 25.12 inches. 25 and 12 hundredths of an inch. All right, now we're going to find the circumference in terms of pi. And this is actually easier, even though it sounds harder. So we know that circumference is equal to diameter times pi, right? That's our formula. For this problem, we're given the diameter, right? This goes all the way across the circle, so that's the diameter. So my diameter is 7, and I multiply that by pi, and guess what? That's my answer. The only thing I'm going to add to this is yards. That's what it looks like when I leave my answer in terms of pi. I actually prefer it because I don't even need to pull out my calculator, right? I just write a pi there. But sometimes they'll tell you use 3.14, sometimes they'll tell you leave it in terms of pi. That's what it looks like in terms of pi. Okay, this time they're giving us the radius and telling us to use a fraction for pi. Okay, so still my circumference is d pi. So if my radius is 14, remember, radius is only halfway across the circle. So that means I would have another 14 over here, right? So my diameter would be my radius times 2. So my diameter is 28 feet. So I'm going to put that in here. I'm going to have 28. And because I'm multiplying by a fraction, I'm going to put it over 1. And then for pi, I'm going to use the fraction that they told me to use. And I'm going to do some canceling. If you don't like the canceling, you don't have to. You can multiply straight across the top, straight across the bottom. I won't be mad at you. But I'm going to do some canceling just to make it easier and like so I can do mental math. So I'm going to divide 28 and 7 both by 7. So 7 divided by 7 is 1. 28 divided by 7 is 4. And 4 times 22 is 88. So this would be 88 feet. And that would be my circumference. That's the distance around the circle. Okie dokie. So another circumference problem, right? This time they tell us the circumference and ask us to find the radius. So we're going to use the same formula, circumference. All right, where's my pen? Okay, hold on. I think we're good. So circumference equals d pi. But this time, we're not going to put in a number for d because we don't know it. But we are going to put in this number in place of c and this number in place of pi, right? So instead of c, I'm going to write 91.688. The d, I don't know what it is. So I'm going to leave it d. And then the pi, I'm going to put 3.14. Now, think back to your solving equations. If d is being multiplied by 3.14, then I undo that by, dividing. So I'm going to divide by 3.14, and that will undo the multiplying. It's the inverse operation. Remember back to module, I think that was module 2. And I'm going to divide on this side as well. And let's see what I get. So 91.688 divided by 3.14 is 29.2. So that's what I get for D, and that is millimeters. But I wasn't asked to find D. I was asked, what is the radius? So if that's the diameter, remember the diameter is twice the radius. So I need to find half of that to know what the radius is. So I'm going to divide this number by 2. So divide by 2, and I get 14.6 millimeters, and that is my radius. My radius equals 14.6 millimeters because it's half the diameter. All right, a few more. Now we have a diameter of the hat. What is the distance around the hat? So distance around is circumference. So we need to use the circumference formula. So circumference equals d pi. This time they do give us the diameter, and they tell us to use 3.14 for pi. So my diameter is 4.7, and I'm going to multiply that by 3.14, Notice I use parentheses sometimes for multiplication and sometimes I use a dot. They're interchangeable, just so you guys know. You probably already know that. You're used to me by now. So 4.7 times 3.14 is 14.758. And it says to round to the hundredths place. So that means I look at the hundredths place and that's where my number is going to stop. So I have to decide, does it stay a 5 or does it go up? Well, there's an 8, so 5 or above, give it a shove. So this is going to become 14.76, and it's inches. That will be my circumference. That's the distance around the hat. All right, company would like to replace the label on a can of soda with a radius of, if the label touches end to end with no overlap, what is the length of the label? Wow, this is tricky to picture. So let me use this. So let's say this is a label on a can, right? So I'm going to curve it so that it looks like a label on a can, right? It's the label that wraps around a can. So it says that the radius, it tells me the radius of this circle on the top. And then when I unroll it, they're asking us to find the length of this label. So now when I roll it up again, you'll see that what they're actually asking us for is all the way around, right? Which is the circumference. So I'm going to use, since we have to use a fraction for pi, I'm going to write this as a fraction as well. My radius is 3 1/4. So I'm going to write that as an improper fraction. So that would be 4 times 3 is 12, plus 1 is 13/4. And then I'm going to double it because I want the diameter, right? So my diameter is going to be my radius times 2. And that is going to be, I'm going to do a little canceling, divide by 2. And that's going to be 13/2. So this is my diameter. All right, so now for my circumference, I'm going to do d pi, diameter times pi. That's going to be 13/2 times 22/7. I'm going to do a little cross canceling. Again, if you don't like the cross canceling, you don't have to do it. You can just do top times top and bottom times bottom. But I'm going to divide by 2 and divide by 2. And then 13 times 11 is 143/7. That's not divisible, but I'm guessing since they gave me the measurement as a mixed number, they might want me to give this as a mixed number. So 143 divided by 7, it goes in 20 times, right? So 143 divided by 7, it goes in 20 times because that's 140, right? With 3 left over. So that would be, just kidding. So that would be 3/7. 20 3/7 would be the length, oh, and that is centimeters, would be the length of the label. Now, if you made that into a decimal, 143 divided by 7, you would have gotten, if I round, approximately 20.43. All right, one more. All right, we have 2 restaurants that offer large pizzas using different measurements for the diameter. This is, true story. Okay, well, except for restaurant 2. They don't tell you the circumference, but I guess, wait. Oh, I guess those are both diameters. Oh, one of them's in centimeters. Okay. Anyway, okay. So one large 14-inch pizza for $12.99 or one large 36.83 centimeter pizza for $12.99. If 1 inch equals 2.4 centimeters, what's the length of the crust around the larger pizza? Okay, so it sounds like first we have to convert centimeters to inches. So remember our unit analysis that we did way back in Module 3? Here it comes again. So 36.83 centimeters over 1, and I'm going to multiply by my conversion factor, right? I need centimeters on the bottom because I need it to cancel. So 2.54 centimeters goes on the bottom and 1 inch goes on the top. So then I end up going straight across, and I'm going to do 36.83 divided by 2.54, and I get 14.5. So this is a 14.5 inch diameter pizza, right? So now it says, what is the length of the crust around the larger pizza? So that means restaurant 2 has the larger pizza. The diameter is 14.5 inches, and I have to find the length of the crust, so the circumference of that pizza. So circumference is d pi. So my diameter is 14.5, and they tell me to use 3.14, and I'm going to do that right now. 14.5 times 3.14 is 45.53 inches. We converted to inches. So that is the length of the crust around the larger pizza. So there's a whole lot of extra information here that we didn't even use. We only used this to know that it's the smaller pizza. We didn't use the price at all. All right, that's it. As usual, any questions, let me know. I'm happy to help.